Hi everyone, today we're going to take a look at gravimetric analysis and the calculations that are involved with it. In gravimetric analysis, what we do is we collect a product, and usually it's a precipitate or a solid formed from a chemical reaction. We dry it out, and then we weigh it, and then we take that mass and we use stoichiometry to go backwards to find the reactants. And so what we're going to do is there's a couple of important pieces of information that we need. So let's go ahead and take a look, and we'll set up the equation for you. So here we have gravimetric analysis set up by this equation that just appeared. And with this equation, what we're going to do is we're going to take this equation and we're going to take this product that we're going to collect. And so the given amount that we're given, maybe hypothetically we collected and we did an experiment, was that we collected 1.257 grams of PBBr2. And then the other information, or the other piece of information, is maybe we wanted to find how much sodium bromide we started off with, or how much we used. Maybe we don't know. And the other piece of information we need to know is that we needed to have an excess amount of one of the reactants. So if we wanted to find the sodium bromide, then we had to assume, or we had to figure out or calculate that we had an excess amount of lead 2 nitrate. So that's the setup that we have. So we're going to take stoichiometry. We're going to take those steps and go backwards. And so if you remember the steps in stoichiometry, I'm just going to use this area. Remember, the first step is to balance the equation. The second step is to convert from grams to moles. The third step is to use the limiting reactant, but since in this case we only have one reactant that we've made limiting, the other one's excess, we already know that there's a limiting reactant. So it would be sodium bromide. That's where all the bromine came from. And then how we'll use the mole ratios to determine that. And then if needed, and in this case it does happen, we'll convert from moles back to grams. All right, now that we have our steps and our information, let's go ahead and follow the steps. So the first step is to balance the equation. So over here we need two coefficients. So we need a 2 here in front of the NABR to balance out the bromine. And we also need a 2 in front of the NaNO3 to balance out the nitrates and also the sodiums from over here on this side. So once we balance out the equation, we need to convert from grams to moles. We're going to take 1.257 grams of the product because that's the only thing that we have the grams measured of. And then why don't you go ahead and practice for yourself converting. So we'll take grams on the bottom, moles on the top, because we want to get to moles here. So I looked it up, and it was 367.01 grams per mole for the molar mass, since it says moles and grams. So we're going to put that on the bottom, 367.01. And then we'll cancel those out. And then we end up with 0.00342497 moles of PBBr2. All right, next, the limiting reactant. We already figured out that we made this the limiting reactant, the sodium bromide, which is the thing that we want to find. And we made the other reactant in excess. So then that way we know that because of the conservation of mass, all of whatever is here should have come from this compound here. So because of the mole ratios, the ratio should work out because this is the limiting reactant. So let's take a look. So we'll take those moles of the product and we'll work our way backwards to find the moles of that reactant. So we'll take the 0.00342497 moles of PBBr2, and then we'll use our mole ratios. So we have moles on top, moles on the bottom. So since moles of PBBr2 is over here, we're going to put that on the bottom of our conversion factor. And then we want to get back to this reactant, so we'll put NABR on top. All right, where do the numbers come from? They come from the coefficients, just like we did with stoichiometry. So since there's a 2 in front of the NABR, we're going to put a 2 here. And then there's a 1 here in front of the PBBr2, so we'll put a 1 here. And then when we cancel out, we'll cancel out those units, moles of PBBr2. And then we end up with 0.00684.994 moles. of NaBr. All right, so we have that there. Now what we're going to do is we're going to follow the last step, because now we have the moles of NaBr, which we went to over here. And then the last thing is we want to find the grams. I transcribed the moles of NaBr we just solved for, and so the last move, the last step, step 5, convert from moles to grams. Since we're here, this is 0.00684,994 moles of NaBr, and we're going to solve for grams. So we're going to put the moles on the bottom to cancel it out. We're going to put the grams on top of NaBr. And so I looked up the molar mass, and the molar mass is 102.89 grams per mole. So in this case, since the grams are on top, we're going to put the molar mass 102.89 on top. The moles cancel out, and we end up with the grams. And so the grams should equal 0.704790 grams of NaBr. And then for sig figs, well, we had 1, 2, 3, 4 from the initial mass reading of the precipitate. So we need 1, 2, 3, 4. So we'll round over here where the 7's at. So we'll end up with 0.7048 grams of NaBr. And so we went backwards from the product that we collected, and we just basically used our principles of stoichiometry in gravimetric analysis. So don't forget, you just need to follow the steps of stoichiometry and then work from your product, and then just work backwards, and then just make sure that you are solving for the moles or the mass of the limiting reactant.